Hey everyone, this is my 4P project that I did on elastic collisions, and here's a photo of Nathan inside a Newton's cradle, which is an example of an elastic collision. My question was, how does mass affect the velocities right after impact of a ball in an elastic collision? The materials that I needed for my project were duct tape, string, scotch tape, two 40-gram balls, one 146-gram ball, one 2-gram ping pong ball, a ruler, and a scale. For my procedure, I would bring one ball to table level, drop it so it hits the ball that was at rest, and then I would change the mass of the ball being hit and repeat step 1. And then I did multiple trials with each different mass so I can get more videos to put into the software, and then finally I would put the videos into the software and then analyze the data that I got. So this is what my procedure actually looked like, and I put them into 3 YouTube videos that I couldn't figure out how to play in this presentation, so I'll just explain it. I would bring one ball to table level and then drop it so it would hit the other ball that was at rest, and then I repeated this same procedure but with different mass balls. In the middle video you can see a lighter ping pong ball, and then in the last video you can see a heavier massage ball. So these are the data tables that I got from the software after I set the scale and plot all the points that I wanted on the video. And you can see these little red circles right here. That's where the collision actually happened, and I could tell because of the change in the X and Y values of each ball. And these are the tables of the balls being collided with the same mass. Rest. These are the values that I got when I changed the ball at rest to a ball with more mass. And finally, these are the values that I got when I changed the ball at rest to the ping pong ball with less mass. These are the graphs that I got from the software, and this is the graph of the balls with the same mass, graph of the balls with bigger mass, and the graph of the ball with the smaller mass. All of these values right here are the velocities of the ball right before it impacted the other one. And these 3 right here is the ball with the same mass, these 3 here are the ball with more mass, and these 3 here are the ball with less mass. And I took all these values and just averaged them out. And this final velocity right here is just the velocity right after impact, and these 3 are for the same mass, these 3 for more mass, and these 3 are for the less mass, and I average all those out. Since kinetic energy in an elastic collision is conserved, I was able to use the equation kinetic energy initial is equal to kinetic energy final, which is also just 1/2 mv squared plus 1/2 mv squared is equal to 1/2 mv squared plus 1/2 mv squared. And for the masses, I just used the masses of the balls, and for the initial velocity, I used these values, or the average value right here, which was the velocity right before impact. And I used all these values to find the final velocity of the ball using the equation. And for the ball with the same mass, I found a final velocity of 2.01 meters per second, which is pretty close to the average I found from the graph of 2.07 meters per second. And for the ball with more mass, I got a final velocity of 1.19 meters per second, which is pretty close to 1.14 meters per second. And then with the ball with less mass, I got a final velocity of 3.79 meters per second, which is also very close to 3.34 meters per second. For my conclusion, I found that the mass of the ball being impacted does affect the velocity it goes after it is hit. If the mass being hit is greater, it will move with a slower velocity. If the mass being hit is lighter, it will move with a faster velocity. And this is because kinetic energy in an elastic collision is conserved. In the equation K initial equals K final, if mass is greater or less on one side of that equation, then the velocity would have to be greater or less on that side of the equation to keep the equation equal. One of the weaknesses of my experiment is that the dropping of the ball was not exact/consistent every time. The ball might have hit the other ball at an angle, which would cause the velocity after impact to be a little bit different. If I were to do this experiment again, I would use some sort of placeholder to drop the ball from to make sure that the drop is the same every time. And that's my project. Thanks for listening.